first SAT using the SAT3 math program. So what we're going to do is we're going to do this College Board, Test 1, Section 2, Module 1, which is the first math section on the practice SATs as of early 2024. So look, first thing we're going to do is go to this option 5 for percents. And we're going to do A is B percent of C, because what is the A? A is 10% of 470. So we're going to use option 4 there of the submenu. So A is the unknown, that's the what. And then B is that 10%. And then the C value is 470. And bam, we got it. Answer's 47. Love it. Okay, oops, whoa, okay, cool. And then number 2, we're going to actually go through the program twice here. First one is we want to solve something. So we're going to go to algebra equations. And then we're going to solve an equation there. And so we can do 4x plus 6 is going to be the left-hand side of this equation. And so notice I'm putting the x up here. I know there's x's other areas on the calculator, but when we use the variable x, we're going to use this one up here in the upper left-hand corner next to the alpha key. So we're going to do 4x plus 6, and then the right-hand side is going to be 18. And then we get, wow, okay, x equals 3. So I'm just going to write the x equals 3 thing. And then what we're going to, all these, if you notice, all the answer options are 4x. Now you can do it by hand, or what we could do is I added this feature to the calculator. I'm programmed the SAT3. We're going to go back to algebra equations. And then we're going to plug in a value. This is cool. So with this thing, what we can do is y equals 4x, right? We could say 4x. 4x equals what? So 4x, and then the x value is going to be 3. And then bam, we get 12. So basically we're saying, 4x equals 12. That's kind of what we're saying using that program there. Okay, now, question 4. We have x squared plus 9. X squared plus 9 equals 25. So we're going to go do, because that's what we're saying, the gx equals this and gx equals that. So we're going to say this equals that. The x squared plus 9 equals 25. So we're going to go to quadratics. And then we're going to go to solve x squared, solve an x squared equation. And then we're going to do, it just has all this warnings, like don't try to do crazy stuff here. You'll get an error message. So we're going to do x squared plus 9 for the left-hand side. And the right-hand side, we're going to get 25. And we're going to get different x values here. We get x1 and x2. I think it wants the positive x value. So we're going to choose option 4 here, or answer 4, which is A. That's cool. Okay, and then we continue. And then, wow, okay. Looks like we have another thing we can use a calculator for. Function f is defined by f of x equals 7x plus 2. What is the value of f of x when x equals 4? Again, this is one of those algebra equations. We're going to do plug in the value. I really like this thing. So y equals, y is generally the same as f of x. I don't want to debate the finer points of that. So we're going to do 7x plus 2. And then what happens when x equals 4? We'll find out in just a second. Okay, so it's 30. So the answer for this one is 30. Awesome. So then we go to, looks like we have a system of 2 equations going on. So I'm going to, what I want to do is I want to first make this into a format that's easier for the calculator to understand. So first thing it says, hey man, we've got y equals negative 3x. I'm going to add 3x to both sides. And then what happens here is we have 3x plus y equals 0. So that's going to be my A equation. My B equation is going to be 4x plus y equals 15. Now, this is going to be algebra equations and then system of 2 equations. Actually, that was like way common in the SAT pre-2024. So that's why it was the first option there. So what we're going to do for the A equation, ax plus by equals c. Now notice it's, and I'll write it a little bit nicer here, 3x plus y. Now if we don't have a coefficient for a variable, like in this case the y, we're going to assume it's a 1. So it's going to be 3x plus 1y equals 0. So the A is 3, and then the B is 1, and then the C is 0. And then we enter it again for the B equation, 4x plus y equals 15. So 4 is the coefficient of the x. And that's going to be, again, a 1, because we don't have a coefficient in front of the y. We're just going to assume it's a 1. And then we're going to assume f is 15. And it gives us the x and y value. So what is the x value? Oh, we're going to go with x equals 15. Okay, great, fantastic. Okay, now for number 11, what we have to do is we have to do a little bit of thinking on our own, or a little bit of work. That's going to definitely be a linear equation we're going to work out here. And we're going to assume it's 2 points were given. So let me walk through this a little bit. First, we're going to assume this like blue point because we want points that are close to a corner here. So it's close to 1.9. I know it's not exact, but what we're trying to do is we're trying to get a general formula of the LSRL, or least square regression line, or line of best fit, depending. It's called different things to different people. But this next point is going to be 4, 3. So the big thing we have to do now is talk about that first point and the x and y values. So the x value is 1 and the y value is 9. And this next point is 4, 3, and check it out. Now, of course, it's the SAT, so it's never like totally easy. What we have is the standard form, y equals negative 2x plus 11. So immediately I can eliminate, bam, the y equals positive x thing. So it's option A or B. But now it looks like it's closest to B, because we have this plus 11 thing. So it's going to be not exact, but it's close. Like what's close? Appropriate linear model. Oh, y equals negative 1.9x plus 10.1. Fantastic. So we continue going down here. And then we have question 14. That to me looks like a quadratic. And that's in standard form, ax squared plus bx plus c equals 0. Now, please forgive me. I know it's a z. And oh, here's that other thing. It's a z squared. So we're going to assume that's a 1z squared. So what we're going to do is solve it in standard form. We're going to assume that a, that coefficient, that ax squared plus bx plus c, the a is 1, the b is 10, and then the c is negative 24. Now notice there's this negative sign here. In our minds, we can distinguish between negative and minus, or negative and minus, or vice versa. But the calculator is very particular about using this as your negative sign. So negative 24, you want to put this right here, right to the left of the enter key here. So we're going to do that. And one of the solutions is 2. So answered that. Awesome. Okay, we go down. Ooh, 18. That looks like a linear equation to me. I bet it looks like a linear equation to you too. Okay, so we're going to choose option 2, linear equations. And again, we're going to go given 2 points. So that first point here, this red point is the y-intercept is 0, 40. Okay, so I'll enter that as 0 and 40. So 0, 40s are x1, y1. And then what I'm going to do is change to blue color. I am going to try to change to blue color here. This is 60, 0 here. So that's 60 as my x value, and then 0 is my y value. And then looks like standard form is y equals negative 2/3 x. So immediately I can eliminate, hey, it's not either of the standard forms because those are y equals positives. Now what I'm going to do, the slope-intercept form, the standard form, 2x plus 3y equals 120. So I'm going to write that down here, 2x plus 3y equals 120. Typical SAT style, it's being tricky. So what I want to do is multiply everything by 4. Now I know you can't multiply equal sign by 4, but just forgive me, I'm doing it street style to save time. So that's going to give us 8x plus 12y equals 480, which is cool because that coincides with option B there, or answer B. Okay, we're going to continue soldiering on. So what we do is 21, a circle in the xy plane is diameter, endpoints, 2, 4, and 2, 14. Man, so that makes me think it's going to be the circle submenu. And then we'll do equation of a circle. And then it's giving us diameter endpoints, 4 there. So x1 is 2, and then the y1 is 4. And then the x2 is 2, and y value is 14. And then check it out. We got the radius is 5. Yay, radius is 5. Because it's got the x minus 2 squared plus y minus 9 squared is 25. Okay, so that solves that. That's awesome. Okay, and this is the last one we do for the day. Okay, so what's going to happen here is this is a quadratic. Okay, and it says it intersects the line y equals c at exactly 1 point. So that means, man, that's going to be a max, because it's a frowny parabola because of that negative x squared thing, the negative x squared plus 9x minus 100. So we want to solve for the intercept or max min, so that's option 3 there of quadratics. A is negative 1, because again, the negative without a number there, we're going to assume it's a negative 1 as a coefficient. And then the B is 9. And then the C is negative 100. Again, that negative key coming in handy today. And then it looks like the max point is negative 79.75. And then let me show you a trick here. Now you could plug all these in, but you could do this. Watch, negative 79.75, and then press math, enter, enter. Check it out, negative 319 over 4. You probably didn't know you could do fractions on this calculator. Fancy, fancy, look at me. Okay, so this is great. This is the SAT3 program available on the site. And then we're going to keep making changes to it over the summer of 2024. So we can answer probably closer to 50%. I think this is like topping out right now at about 33, 35% of the questions on the test. Again, we're going to do a series of these, so you can select the second part, which should be up within a day or two. Okay, take care and good luck in all your math endeavors. I'll see you next time.